Well, we've made it to our last lesson on quadrilaterals. We've talked about parallelograms, rectangles, squares, rhombi. But now we get to end on these two cute little guys, the trapezoid and the kite. We're going to start with the trapezoid. Here we go. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Those parallel sides are both called bases, not just the bottom one. And the not parallel sides are called legs. So here we have trapezoid A, B, C, D. Now there's a special kind of trapezoid called an isosceles trapezoid. And if a trapezoid is isosceles, then each pair of base angles is congruent. Now we can kind of flip this around and say, if a trapezoid has one pair of congruent base angles, then we know it's an isosceles trapezoid. We know some other things about trapezoids too, like a trapezoid is isosceles if and only if its diagonals are congruent. So AC would be congruent to DB. And the midsegment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. That sounds a bit confusing, but it's like in the middle of the trapezoid, and it cuts the two legs in half. And the cool thing is that the midsegment of the trapezoid is parallel to each base, and its measure is half the sum of its bases. Or you could say the measure of the midsegment is like the average of the bases. So let's put that into practice. We need to find the measure of angle y. We're only given one angle in here, but we're given two congruent legs. Those two congruent legs are pointing to the fact that we have two congruent base angles, so 68 and 68. We also know that the total degrees in a quadrilateral is 360. So if we take 360 and subtract those two 68s, we get 224 degrees left over. That 224 degrees we just split into two, and we get the measure of y equals 112 degrees. Let's try another one. If LK equals 19 and TS equals 15, then we need to find HJ. Now we know the midsegment of a trapezoid is parallel to each base, and its measure is half the sum of its bases. So TS is half the sum of HJ and LK. So we can kind of plug in what we know. TS is 15, LK is 19. We're looking for HJ. Let's multiply both sides by 2 to get rid of that fraction. So we get 30 equals HJ plus 19, so HJ equals 11. So those are trapezoids. Now we get to move on to these quirky little things, kites. A kite is a quadrilateral with exactly two pairs of consecutive congruent sides. The opposite sides of a kite are not congruent or parallel, which means for this kite, AB is congruent to BC and CD is congruent to AD. Kites also have some fascinating properties. We know that if a quadrilateral is a kite, then its diagonals are perpendicular. We know that if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So like the head and the tail, those would not be congruent angles. So let's use that information to find angle Q. This is a quadrilateral, so the total degrees inside a quadrilateral is 360 degrees. We have two angles that have been labeled for us, 110 and 48. So let's subtract those from 360, and we get 202 degrees left. We can take that and divide it by 2 because we know that those opposite angles are congruent. So 202 divided by 2 is 101. That's the measure of angle Q. In this last one, we need to find BC. We're given some measurements in the diagonals, and we know that the diagonals are perpendicular, which means BC becomes the hypotenuse of a right triangle. We can now use the Pythagorean theorem to solve for BC. 4 squared plus 7 squared equals BC squared. 65 equals BC squared. If you take the square root of both sides, you get that BC is the square root of 65. We've learned about all kinds of quadrilaterals in this unit: rectangles, parallelograms, rhombi, squares, kites, and trapezoids. And each one has its own special set of characteristics that we can use to either solve problems or identify relationships or whatever. So thanks for hanging in there during this unit. It was nice to have you here.